Alright, a quick little lesson on scientific notation to wrap up everything we need to do with this chapter. So you see your warm-up and you guys know what's going on with that. Which one is different? Well, there's a couple ways to look at how it's different, but there's one thing that strikes me that's not in scientific notation, and that's this one right here. Right, because it's the only one with 2 digits there. So that's kind of the problem, although we would know what to do with it, right? Times 10 to the 4th to move this decimal over. But it's not properly written, so that's one thing we have to do, a number in scientific notation. If it is written in the form a times 10 to the nth power, where n is an integer, right? Remember your integers. -2, -1, 0, 1, 2. Alright, NA has to be between 1 and 10. Notice it can be 1, but it has to be less than 10. So that's what we're talking about up here is you can't have those 2 digits there. So we have a couple of different examples there. And I know from your science class you've matched those up. Okay, so here's the next thing. Oh, the first thing I see is this one's really small. That's the only one with a smaller number. So 10 to the 4th, 1, 2, 3, 4. Okay, 68, 3. Okay, and the nice thing about matching here is I know this must be the last one. Okay, so we get our A, B, so CBA to match those up. Just being able to translate them back and forth. Big part of what we're doing. We want to say if these are in scientific notation. Alright, 4.5, yeah, that's good. Okay, this seems to be a little bit too small. We have a problem here. Can't have that addition. If we work down the column here, this looks good. 4.5, yeah, I don't see anything wrong with that. Oh, we got a major problem here, right? It's supposed to be times 10 to some power. Alright, we can have negative numbers, that's okay. And we can have a plain old 3. Alright, so made it through the first column. Alright, second column. Here we go. 5.4 times 10 to the 7th. You look good. 1, that's okay. Times 10 to the 5th. 3.2 times 100. Nope. Can't have this. That's no good. It'll just be 10 to some power. If we change it and wrote 10 to the 2nd power, that would work. Yeah, we're good here. 11 times 10 to the power, it's times 10 to the 5th, but the 11, just a bit too big. Alright, 2.3. Alright, 2.3, that part's okay, and 10 to the 5th. 6.2 is okay, 10 to the 4th is okay, but we can't use division here, so that's no good. 10 to the 5th, we're multiplying, but 56 is no good, because it's too big. Alright, so if we actually wrote them over here, that's fine. But if we just circle what's wrong with those, that's a pretty good start for our scientific notation. We'll be able to translate those back and forth. So we know that this should be 7.9 times 10 to the 12th. That means we're going to move this decimal 12 places, but it only requires 11 zeros. And I think it is helpful for both of us to put commas in so we can see what's going on with those. Remember, the decimal point is right after the 5 here. This time we're going to go to the left. 1, 2, 3. Okay, so that's what we want to see there, 0.005. And even if there are multiple things there, so that's why it has nothing to do with the number of zeros, it has to do with the number of places you're going to move the decimal. So 1, 2, so we still have 4 to go. 1, 2, 3, 4. 4 decimal places. So we're able to translate those. Alright, so out of this whole number here, where should our decimal point go so that it's between 1 and 10? Well, it should go right here. So we know we want 4.7423 times 10 to this is a large number. So here's 3, 6, 7, 8. So 10 to the 8th. Okay, and our next one, we know we want the decimal point to move to in between the 3 and the 7. It's 1, 2, 3, 4, 5, 6, 7. So it's times 10 to the 7th. But this was a much smaller number, so it must be negative 7. Okay, so again, between science class, I know you're familiar with a great deal of this. So we'll keep moving here. We want to write it in the standard notation. Okay, so that means we need to move this thing our 6 places. So 1, 2, 3, 4, 5, 6. Here we go. Temperature at the sun's core. Okay. So that's what it looks like. So sometimes it's deceiving to think that it's 1.55. So when you write it out in standard form, you get an idea of exactly how hot that really is, even though we don't use Kelvin. Mass of the smallest insect. So here's what it looks like under a microscope. So you definitely, you don't want to freak out about that thing. But realize how small this thing is. So times 10 to the negative 6. So that means we're going 0, 2, 3, 4, 5, 4, 9, 2. Right, you move 6 places. 1, 2, 3, 4, 5, 6. Yeah, that's it. Okay, that's how much of a gram the smallest insect weighs. Alright, so it's scary to think that thing could be right in front of us. We'd never see it. Alright, so maybe something you have to do new for math classes to compare them. Okay, so the map shows 4 major world oceans, surface area. So we want least to greatest. Okay. So if I want the least, that means if I'm going to start by looking at those exponents first. So I know the Arctic and Indian Ocean have to be the smallest, because something times 10 to the 7th is always smaller than something times 10 to the 8th. Okay, so that means the smallest is going to be number 1, the Arctic Ocean, because now I'm going to compare that A value. So this must be number 2. As we move on to times 10 to the 8th, what's going to be smaller, 1.06 or 1.8? And the Atlantic Ocean will be that, and that's making the Pacific Ocean our largest. Okay, so if you'd like to rewrite those, you can, but not required for this type of problem. We just list the order. So one thing that is helpful using scientific notation is to make sure that everything is either in standard or scientific notation. So one thing we have to do is be able to use scientific notation to order them. If 49 is too big, it's too big by 1 place. So we do plus 1 to the exponent. So it's 4.97 times 10. And it was to the first power, so now it's to the second power. Our second number, 4.17 times 10 to the 7th, is in proper scientific notation. Our third number is not in proper scientific notation. It's too small. So I'm going to say minus right after that 9, and it would be 2 places. So we're going to say the third number is 4.7 times 10 to the 7th. And our last one, it's in standard form. So if I want to make sure that these look the same, I'm going to say that this is 495 times 10 to the 0 power. I have to move 2 places, so plus 2. So it's 4.95 times 10 to the second power. So I'm going to be able to translate numbers that are not in scientific notation until they are. We again want to go least to greatest. So the first thing I look at are the powers. So those have to be my smallest, and something times 10 to the 7th have to be the largest. So 4.97, 4.95. So 4.95, you're the winner as the smallest number. And then the second one, 0.17 or 0.7, 0.17, and then 0.7. So we'll make sure we can translate those. Okay, the first one's probably the trickiest one because, again, we don't write 1 as an exponent. So when I went to write plus 1, that's why it becomes 2 in the end. Alright. If they're already in there, you guys can deal with this in some science class as well. The proton, the neutron, and the electron. Okay, so we want this least to greatest, right? So the smallest one. So that's the electron. Everybody knows that. The next thing we have is both to the negative 24th. So we're checking these out. So the proton, you, my friend, are number 2, and the neutron is number 3. The neutron being the largest item that we have. Alright. So, if we want to multiply, here we go. 7 times 4 is 28 times 10 to the 5th. And hopefully what you have picked up in the last few problems is that this is too big. So we have to move it too big by one place. We're going to do plus 1 on the exponent. So 2.8 times 10 to the 6th would be the proper scientific notation. Okay, so that's a result from our multiplication. If we just give you an example like 2 here, and you notice that it's too big by one place, too big means put a plus sign, one place is all you have to move it, so 6.73 times 10 to now to the 5th. And we notice in example 3, this is way too small, right? We have to go 1, 2, 3, 4 places. So I have to do minus 4, right? Too big, we add on to the exponent. Too small, we subtract it. Yeah, I don't worry about left and right, all those things. So negative 6 minus 4, that's negative 10. So now we're in proper scientific notation. Alright, so you should be able to go through your Do You Know How and check those in your group. Okay. In proper scientific notation. In standard notation, that means to write it out. And then to order them, right? We can just say 1, 2, 3, 4. Make sure you go least to greatest. First one is super duper simple, right? Because all I have to do is look at the powers. They didn't give me an A value. Alright, and then down below, we're doing all for homework. It looks like a lot, but when you realize it's the same thing you just did, it should go pretty quickly.